you how to solve an exponential word problem from the Calculus and Vectors grade 12 textbook. The question states that the mass of radon in milligrams as a function of time is given by the function mRn of t, which is equal to mo 1/2 to the exponent t over 3.8, where mo is the initial mass of radon and mRn is the mass of radon after time t in days. Part A says how much radon will remain after 1 day and 1 week. Part B says how long will it take for a sample of radon to decay to 25% of its initial mass. And Part C says at what rate is the radon decaying at each of these times. Now I highlighted two parts here simply because the first highlighted part up here tells us that this particular question is from the Unit 5 Derivatives of Exponential and Logarithmic Functions unit, because there's a variable in our exponent and just an exponent in general tells us that. Also, if we read down, it says at what rate is the radon decaying at each of these times. We know that this is a key element of the question, because at what rate is asking for the rate of change at a certain time, and this is what all calculus and vectors is about, is finding derivatives so that we can find the rate of change. So let's solve these questions. So part A says how much radon will remain after 1 day and 1 week. The keys to look out for in this part of the question is when it says 1 week, that refers to a t-value of 7 because we're looking at time in days. So make sure you put t in as 7 in that scenario. So when we're looking for this, we're trying to find out after how many days how much radon remains. So simply all you do is you plug the t values, so your time, into the t variable, and then just solve for your equation. So as you can see, mo, which is our initial value of radon, is actually 100 milligrams. So that's given to you at the top of the screen. Then you just simply use your equation and plug in the t values. So as you can see, after 1 day, the mass of radon has decreased to 83.3 milligrams from 100 milligrams. And after 7 days, the mass of radon has decayed to 27.9 milligrams. So this is an exponential word problem, but because our base value, which is our value in the brackets of our equation, is 1/2, we know that this equation is going to be a decreasing exponential word problem. Therefore, the mass of radon is going to be decreasing. We can tell this if the b value is less than 1 or greater than 0, then we know that our exponential word problem is decreasing. Okay, so part B is on the right side of your screen now. And part B says, how long will it take for a sample of radon to decay to 25% of its initial mass? So what you need to key on in this part of the question is it's saying how long, which means we need to find the time value. Now in this case, our time value is in our exponent, which means we will be needing to use logs. So in this question, you have your original equation of mRn of t is equal to 100 times 1/2 to the exponent t over 3.8. Now it says we want 25% of its initial mass, therefore 25% of 100 is 25 milligrams. So you set the left side of your equation, which is the mass of radon, equal to 25. So you can see we did that in this step here. Next, you need to get the base value alone, which is 1/2, so you divide both sides by 100. To get 0.25 is equal to 1/2 to the exponent t over 3.8. Now that our variable is in our exponent, and that's all we need to solve for now because we've done simplifying the equation, we need to use logs. So to get the variable out of the exponent, we log both sides. So you can see we logged 0.25 and we logged 1/2. And then you bring the exponent, t over 3.8, into the coefficient of the right side of the equation. Next, you want to get the variable by itself. So you isolate t over 3.8 by dividing both sides by log of 1/2. So we did that here. So dividing log over 1/2 gets you 1. So now we have log of 0.25 divided by log of 0.5 is equal to t over 3.8. Now if you do log of a quarter divided by log of a half, you simply get 2. So you get 2 is equal to t over 3.8. Now finally, to solve for the t value, which is time in days of how long it will take the radon to decay to 25% of its initial mass, you cross multiply and get that 7.6 is equal to t. Therefore, it will take 7.6 days for the mass of radon to decay to 25% of its initial mass. Okay, so part C is on the left side of your screen now, the very far left. And the question says, at what rate is the radon decaying at each of these times? Now remember that at what rate was one of the key elements of this question, because it is asking you to find the rate of change, which means we need to find the derivative of the equation. So for an exponential equation, what you want to do is you want to take your equation and multiply it by ln of the base value, and then multiply that by the derivative of the exponent. So there are different sort of factors affecting this, but if you have an equation, so f of x, and then you also have an f of x in the derivative, the rule is to always multiply by ln of the base and then the derivative of what's in the exponent. So that's what we have to do here, because we have a function with another function in the exponent. So at what rate is the radon decaying at each of these times? The times are referring to t equals 1 and t equals 7 from part A, so t being 1 day and t being 7 days. So once we find our derivative, so first of all we have our equation mRn of t is equal to 100 times a half to the exponent t over 3.8. So now what we do is we solve for our derivative. Our derivative in this case is 100 times a half to the exponent t over 3.8 times ln of a half, because a half is our base value, times 1 over 3.8, because as you recall, over 3.8. So we multiply it by 1 over 3.8. So once you do all this, you can just plug all your variable of 1 into your t and solve mRn of 1 to find at the rate at 1 day. And you find negative 15.2 milligrams, so therefore at 1 day the radon is decaying 15.2 milligrams. So now that we have our derivative, we just sub the second variable into t, which is 7. You do the exact same thing, you come up with negative 5.1 milligrams. Therefore at 7 days the radon is decaying 5.1 milligrams. So a profession that would include questions like this, so finding how long it takes for radon to decay to a certain mass, how much radon will remain after a day and a week, and what rate these radon is decaying at, is helpful in medicine or as being a doctor, because as being a doctor you need to know how much of the antibiotic or whatever you are placing in your patient's system, how much there's going to be, how much there's going to be left at certain time periods, how quickly it's moving through your body, and when it's going to be at a certain level. So that's one profession where you need this. So it is very useful to be able to know these types of questions. So thank you very much for your time, and I hope you have enjoyed the video.